start with some basics. Everybody knows what Arexx is. It's a scripting language. It's both a scripting language, but it's also a series of message ports. Yes?
What does it mean?
The very best scripting language in the world. It means AmigaOS. Arexx was originally a mainframe scripting language that IBM came up with, and the Amiga decided to make it better. And the best thing about it is the fact that you've got messaging. You can create on any application, Arexx application, C application, Python, whatever, you can create message ports, which means you can receive messages. You can send messages. And it becomes a many-to-many messaging method. So a lot of times when people say Arexx, they could either be talking about a script, which is like basically a program comparable to BASIC or something like that, but no GUI. Or Arexx could be just the act of sending messages. Those messages could be going between two C programs. They could be going from a Python program to an Arexx program, whatever. It's a format of message on the Amiga. So, again, as with everything else, everything I'm going to tell you, everything in here is on the wiki. So you guys can all look this up when you get home and you have internet again. And right there, Arexx port message. There's also the LHA file, the archive with the examples that you guys got is on here also, the bottom of the script. So it's possible then to download it again if you need to. So the tutorial I'm going to go through is also all right here. So getting into the nitty-gritty of it, you've got to do some preparations in your application to be able to do Arexx. Arexx, just like everything we talked about this morning that Steve went over, Intuition used to have this longhand way of doing windows and window structures and all that. Under OS 4, they came up with the idea of an Arexx object and an Arexx class. And that Arexx class went to really simplify the work that's involved in doing the things we're going to talk about. Again, just like if you're a control freak with Intuition, if you really want to get into the nitty-gritty and do some of the more really sophisticated or powerful things, you may end up having to dig down and get into the old-fashioned way of doing it. There are ways to pass messages and variables and things like that, really pretty more complicated things. And there's documentation which eventually will make it onto the wiki that Commodore had for developing with those methods. Using the method that we're going to talk about, this simpler method, again, it uses the Arexx class. Just like when you guys were looking at doing how to make a window, you have to initiate an object. You're actually going to call the exact same function. You're going to call the boopsie new object function right here. In this case, instead of calling the window function, you're going to be creating an Arexx object. That Arexx object, just like you guys saw with the window function, you've got certain tags. These are the parameters that dictate what kind of an Arexx object you're creating. This is a list of all the common tags that you guys can call depending on what kind of an Arexx port and what kind of things you want to do. We could go over this really quickly. The way it's set up is that typically you will have you'll give your application a message port. That's the common way to do it, that you have the ability to receive messages even if you're not planning to. You have a name and there's something associated with you. There's the tag that is no slot. I don't know if you guys have ever noticed Arexx message ports, like for example, AmiIRC. When it comes up, it's AmiIRC.1. If you open up a second window, it's AmiIRC.2, .3. Those are slots in this regime. The idea is that you can set a tag here, a Boolean tag that says, no, I don't want my port numbered. That'll also mean you can only open that named message port once. If you try to do it a second time, it's going to be an error. But there are some applications where you may want to bring your application up and see if that message port already exists. And instead of running your program a second time, send a message to that port and say, you know, somebody tried to open it a second time, do something with this instance, right? So then you've got the ability to set, if you want to, a suffix, which is normally rex in this case. In some cases you may want to use a suffix that's different. iBrowse uses IBRX, for example. It's kind of not really a major important thing. If your application is going to receive messages, you have to say what kind of messages that it'll receive. And we'll get into this, but you essentially set up a structure of commands and what will be used. The error code comes back and tells you what went wrong if you weren't able to create the Arexx object. So the reply hook is where you dictate what will happen when your application receives a message, a reply to a message. So if you send a message out, Arexx always works that you send a message, the receiver of that message gets it, and then acknowledges it, replies to that message, and your application gets a reply back to the sent message. It's always a two-step process. This function, this reply hook, is what gets called under that case. And then finally, if you want to do the rather esoteric thing of not having a message port, an Arexx message port, you can call a different message port and let that receive the messages. But that's not in any of our examples here now too. So here's an example of what would be involved in setting up an Arexx object. So we go into it and we would declare a number of variables here. The Arexx object pointer to that object, a reply hook, and that's an AmigaOS pointer type that's actually points to a function that gets called as a hook, which means that it gets called when some event causes it to be needed. Then a couple other variables here for a message port name and error code, and then finally the nitty-gritty here where we set all these things. We're creating a new object of the Arexx class. We're giving it a name of Arexx sender. We're telling it we don't want to have the port get numbered, so it says true, no slot true. There's a variable to hold the error code and the reply hook to get the response. So this would be an example of a simple declaration or creation of an Arexx object to simply send messages. This code comes out of the first example that you guys see, the Arexx sender program. So essentially you would call that function, and if it's successful, you end up with a pointer to an Arexx object. That's what you have right here. The Arexx object is going to be the structure, the object that has all the information about this port you just created. At this point now, a port's going to show up and messages can be sent to your application. You have a little bit more to do, but you're getting close. If it fails, these are the common errors here. You know, you didn't provide a command list. If you're going to be receiving messages, you have to provide a command list. You know, your application can receive a message that says help, quit, save, open, whatever. You didn't provide a port name, you know. The port name already exists. This is the critical one if you have no slot true. The port name already exists. That's the error you're going to get. And then obviously the no free memory. And then obviously in all these cases, you should be a good boy or girl and say what went wrong, what you need to do about it, how do we need to fix it. Any questions so far?
Yeah, actually.
Yes?
So I noticed that this is actually an intuition class.
Yes, it's a boopsy class.
So does that mean that I wouldn't be able to write a direct executable be executed by Arexx master over a shell?
Well, in this case, what we're doing is we're basically doing things. You can do this from the shell, and we will do this from the shell because you're not actually opening up an intuition window. Right. You're just creating a boopsy class using the object-oriented methodologies that AmigaOS has.
Right.
So it's not related to you having to open up a window. None of this is.
So if I wanted to create a command line utility that could also be automated via Arexx,
yes,
that's no big deal.
And we're actually going to do that. Right. You've actually got the source code to do that. So
okay.
Now, so we talked about this reply hook that you see right here. And what it is you have to have this little hook that basically says you're telling the operating system, at the point this message comes in, the reply to our message, call this function. And it's this simple little chunk of code right here where we say we're going to have a function that in the case of our program is reply callback. And that function is going to be called when this hook is called up. And this is there, if you if you go into, I think you can go into CodeBench and shift double click on the hook structure or search for the hook structure in the autodocs, and you'll find a whole description in there on how that all works. But this is keeping it to a pretty basic level. There's a hook, meaning that that's something that gets hooked, this function that gets hooked and called up when an event occurs. So what we do is we define a hook structure like this that basically just says we're going to call this reply callback. When this reply hook gets used, this function inside our application is going to get called, right? So that's the second thing we have to set up. Create the Arexx object, set up the hook. And then finally, our application has to have the actual function that gets called. That reply callback function you see here is going to be a function that gets called by the hook, and it's going to be given the Rex message that gets sent to it right here. And essentially, it's a variety of parameters. This is a standard intuition message structure, and essentially that structure gets sent to our application. And I was going to see the results that are in there, the parameters that get sent to us are really these things, the most important things, the result and the result 2. And if you've done things with Arexx, you'll see that you always have result 1 is either 0, that it was a successful event, or an error number. If it's 0, then the second number will have the parameter or anything that might have been sent back. We'll get into that. So those are really, like I said, the most valuable things right there. So that's what gets sent to the reply function. Right here is a very simple little example of the reply function that basically, that's the function that gets called. There's a hook here that is not used in this case. There's the Rex message, RXM. That's the critical thing right there. So the result right there is RXM result 1. So we can print that out, and that tells us whether or not it was an error or not, 0 or a number. If it is 0, which means it was successful, then we can print out the second part of that, and this might be whatever got sent back. So for example, you could send a message to another host and say, the best example I find for our purposes would be the Workbench, which has it's always there and it's got an Arexx port. You can send a message to the Arexx port, help. It'll respond back with a list of all the commands it knows. That would come in that result 2 right there. Yes?
So, is this true of all Arexx? You're going to get the 2 results back, and if the result 1 is 0, then you'll get
a second variable, right.
And if the result is 0,
greater than 1.
0, which means false, you didn't get.
If it's 0, it means that there was no error. If it's something higher than that, that means there's an error number.
Oh.
And that's the error number.
I'm sorry, yeah. So if it's
Right.
0, it worked.
Yes.
And
And if it's 0, then you're going to have
zero
then that number, result 1 right there,
is going to be your error.
is going to be the error number. And you can look that up in your Arexx book. It actually has a list of things, and there's port not found and a whole bunch of other things.
When it is the error, do you get anything in result 2, or is it that it's...
You know what? I think
result 1 is the error, and you don't get anything.
there are
after that.
you don't get anything after that. The error number gives you information, and I believe in the example I came up with a way to check that, but we can take a look at that. So these are the 3 things we need to set up. We got to create our Arexx object. We need to define the hook, assuming we have an Arexx object, and finally we need to have in our code the way to handle the response. 3 fairly simple things, I think. And then we're ready to go on off and send a message. We've created the Arexx object. Assuming that all worked and the Arexx object was successful, then essentially we have to send a message. We obviously need to know a message port, the name of a port to send it to, the Workbench, AmiIRC, another application that we wrote, anything like that. Then send the message, and then we wait for a response, coincidentally using the same wait function that you guys used earlier, and then handle the response. So the first step is to go and find the target port. So let's say in this case we're looking for that port name called Workbench. Now, because on the Amiga you have a multitasking computer and ports could be coming and going at any moment in time, to actually do the search for the port name, you have to do this nasty little thing called a forbid. Forbid says, kill all multitasking. That's what that is right there, forbid. Then you call the exec function find port. You give it the port name, workbench, right here. As quickly as you can, regardless of the result, you come down here and you set it to permit, to let multitasking keep going. Then you deal with what you found. If this was true, then you did find the port. If that failed, the workbench port could not be found. So, obviously, you have to know where to send your message to. That's the test. So, you pass that test, you can see we've got it. As I mentioned a couple times in this document, if it failed, you gotta be either politely tell the user and deal with that, or come up with a way to actually rectify the problem. Maybe they had a typo when they typed the name in the wrong way, or something like that. There are a variety of different ways to handle it of varying levels of elegance. So, if you know you have the Arexx message port, man. If you have the Arexx message port, right there we have it, and whether we found it. Now we can send the message. We're going to, again, this being a boopsy class, we're going to use the same function as we used for some of the things with the Windows. We're going to call the do method function. And except in this case, we're going to call a different, we're going to call it with the Arexx message execute. And we're also referring to the Arexx object. You're not referring to a window and buttons and clicking and things like that. You're referring to Arexx object and sending a message. So when you do that, you pass it a number of parameters. And most of these parameters, you're really going to deal with just a couple of them. The most important thing you're going to have here, the command that you're going to send, which is a string. That's the command that's going to get sent with a message. So you're going to get the command from the user, help. And that's what you're going to put in this field. And obviously the port name that we validated is going to be in this field here. These two are the most critical things in terms of sending out the message. This is going to be set to AM execute, which means you're executing an Arexx message, right? Then finally, this is where things get set that have to do with responses. For the time being, this doesn't apply to us, but that's there. It applies under different circumstances. An example of that code would be right here, where we set the message we're going to send to be help. And right here, we're calling the intuition method, do method. We're referring to the Arexx object, AM execute, the command, which we set up here to help, the port name, which we had previously set to workbench, and then all the rest of this is set to null because we're not sending a result code, we're hoping to receive one, right? So essentially, that sends the message. Now, one of the things that we talked about here, and this is some of the stuff that you guys saw earlier, all of this stuff on the Amiga is very asynchronous. You send the message, the reply may not come that instant. It might come 5 seconds later. It may come a minute later. You don't want to lock your program up over this, so it's asynchronous. You send the message, you can go on doing things, or you can call the wait function. That's what we get into next here. It's that same wait function that you guys used before. And remember, we had all the business about the masks. One of them is the mask that's you have the mask. You have a Control-C mask. You have intuition message mask. In this case, we're going to create an Arexx mask. Arexx sig mask right here. And just like we did before, we're going to do bitwise mathematics, and we're going to combine that Arexx sig mask with the other masks that our application might have. And essentially, this puts our application to sleep and lets our Amiga go do other things until it gets a reply to the message we sent or something else. So this little chunk of code we've got right here is where we say, okay, we've got this Arexx signal, which is just a variable to hold this. We're going to call this intuition get attribute. For Arexx, we need to get the signal mask right there for receiving an Arexx message. And then finally, we're going to call wait with that. our Arexx signal mask, the OR, and then also we'll wait for a Control C. So if something hangs, we can still do Control C and kill our program if we need to. We've put all that in there, we wait. That's going to put our program to sleep until it gets a response. Then again, in this case, like we saw before, we're going to say, here's the signal that we got back, and we're adding to it, and this is basically bit math, we're adding to it the Rex signal, and those two added. If that's true, that means we did indeed get an Arexx message. The way that this gets handled is that we call this function again do method, like we did when we were sending, but instead of am execute up above, we had am handle event. Essentially what that does is it says there's a waiting message, deal with it. That's the point at which the hook gets called and our function gets called that says, hey, we received a response to our message. Let's see what happened. Did we get a reply back? Did it fail? Was there an error? Did we get an answer? What happened? So you guys will see this in the code that you've got there. And if we go, and I will sit down here now, to our code here, ran a second instance of code bench. Bad things will probably happen. I don't know. Okay. So what we have here is this is that sender code right there. So you guys should all see this if you open up in the Arexx sender application. You guys should all be able to open that project up, and hopefully if everything works this time around, you should be able to open it up and see that project right there. Everything, it working for everybody? Okay. And any questions so far? Okay, now we get to see how the shell command actually works. So if you all go into this thing, there's the build button. There's the build, it's finished. Nice, quick, simple little program. In CodeBench, you've got the ability to go over here and open a shell right in the directory where your project is. So that's really a nice, handy thing. So you can come in here and just do Arexx sender. That's the name of our program, to send a message, right? Run the program. Now type garbage. Garbage in, garbage out. Okay. First thing it's going to ask us here is for that name of a message port to send to, right? This case, like I said, the workbench is the one to send it to. The examples you saw were hard-coded to that. This case, what we'll do is we will type it in here. So we just gave it that name right there. And then the message to send it, as I said, help is a really nice command for every program to have. You send a message, help, your program should send back all the commands that your program knows. Really nice, handy thing. In the case with the workbench, you send that. This right here is the reply. 0, no error. Result 2 is that whole string from there down to that point. These are all the commands that the workbench understands. This application asked us, it's asked us for, let's open it up. It made sure the library was opened up, which it gets done automatically if you have L-auto. It set up the reply hook. It got the name of the port to send to. It got the command to send, sent the message, then it went to sleep. At that point it was sleeping. If Workbench wanted to take 5 minutes to do it, our machine wasn't locked up, right? Then it received a reply. It checked what it is, it found out that it's an Arexx message, and then the hook got called when we said handle event. So this all in caps is the hook function being called. And it parsed out of that message what it received. There was no error, so it received that. And then finally, the message had been handled. We're back in the main function again. It closes up, gets rid of the Arexx object, and it quits. Really simple little program. As you know, we were talking about, you can do it from the shell. Now, I'll get out of here. Yeah, and it's, I mean, the nice thing about this is that you can get into it and easily send messages. But obviously the value is also being able to receive messages. So what we'll do is we will get out of there. And we have another one, AROS Receiver. And while that's loading, which I can't do because that bloody splash screen's in front of the browser. This is a philosophical disagreement. I wish that splash screen wouldn't be in front. So what happens here is the Arexx Receiver is another simple little program that I gave you guys there. And we'll go into the text here to go into it. Now, again, in this program, we create another Arexx object. Now, if you were going to have one application that did both of these, you're going to merge the things we set here with the things we set above. The salient difference when you're receiving messages is, you know, you can have no slot, true or false or whatever, that doesn't matter. It just has to do with how your program runs and appears. The critical thing when you're receiving messages is you define now the Arexx commands. And what it is you're going to be defining the commands your program can accept. Help, save, open, quit, whatever. So,
Ignores anything else?
Ignores anything else, yeah. And that's one of the things that if you really wanted to dig down into the nitty-gritty, you could create an Arexx port that didn't have that limitation. But part of the Arexx class, so you can receive any kind of message that's sent to your port. But with the Arexx class, for the sake of keeping things simple and manageable and letting the operating system handle it, you define the commands you can handle, and you define how they can be used. And that's what we get into here next. So this is slightly different, how we define the object. We get down here, and we have a bunch of things we can define in this command structure. Essentially, it's a structure where you have a bunch of different settings for each command that your program can receive and how it gets called. So what it is we've got the name of the command. So in this case, it could be help, save, whatever. Then we've also got just a number. It's a counter. Could be, you know, it's sequential order, number. Then what we have again is a function that's going to get called. In this case, it's just the name of a function within your program. When that command comes in, that's the function that's going to handle it. If your command's going to receive parameters, variables, we got into this a little bit yesterday when we talked about how to start your program up, and you have the ability to define a template that says that your program will receive a keyword called test and a number and a file name and things like that. Well, the same thing here. You can define a template, and that basically lets you parse out the arguments that your application will receive. And it gets sent to this function the exact same way that read args in startup would have sent it to your program at startup in the command line. So it's using the same methodology and the same functionality. I have no idea what this future assignment's for. It's something for the future. Steve knows.
Future argument?
This is the function here where you set it, where it only works for Python. Then you've got here the arg list, and this is the results that come back from that template, right? So the results of read args that was done on the response, the arguments that came to your application. Then finally you have these settings right here, which is how you pass back your results back to the calling application. But we'll get into that. So this is all the stuff you define, and in an example here you'll see this would be how to set this up for a little application, coincidentally the one you've got the sample code of, where these are the commands it understands. Name, version, quit, send, date, help. Help is actually a little chunk of code that I did that'll print out all these commands, kind of tried to make it as modular and future-proof as possible. And basically what it is when name gets received, that function's going to get called. Now it has no parameters or anything, so everything else is nulls and zeros. In the case of send, that function's going to get called, but it's going to receive text as a parameter of the command. So that means if you want to send a command to this little program, you're going to say send and then some text. And that's what's going to come in here. This is how it's going to be formatted, and that read args, that arg list is going to contain that data. It should be the right number of items. And then
The number of arguments.
yeah, it should be the same number as up there. Should. It compiled before I stuck the code in here. So date actually uses a flag, a switch system. So if you send the message date, you get one result. If you send the message date system, you get another result, the system date. That's an example, just another simple example how to do this. So here you see how this structure of Arexx commands, called commands, has got all these items, finally ends up with null entries, and those are the commands that our little application can receive, right? So essentially, you set this up, you go through the same steps, the 3 same steps that we did at the beginning. You open an Arexx object, you define the Arexx object of things. In this case, you don't need the reply hook, the general reply hook, because the replies are all going to be defined up here. We're receiving, unless you're sending out messages. In this case, we're receiving predefined replies, and we have the functions called there. And then what we do is the same as before. We call the wait function, and we wait for an Arexx message. And our application does that. Again, the same as with sending a message and waiting for a reply. We wait for a Rex signal to come to our application. When it comes, we call that same IDO method with handle event. In the previous case, we were getting a reply to a message we sent. In this case, we're waiting for a message somebody else sent us. So in this case, handle event calls one of the functions we defined up here. Rex send, Rex help, Rex. And the functions that handle those, that get called when handle event pops up, then have this format to them. That in the case of our example, we had an example here that was Rex underscore name or Rex underscore send. So that's the name of the function right there. It gets sent this Arexx command structure. That's essentially the format of our command structure, but with certain fields filled in. And then we have the actual pointer to the actual Rex message, which is some of the stuff we set to send a reply back. The structure here uses these items right there. These are the items that we're concerned with now in the incoming message. So you have the arg list that we talked about that is formatted according to our template. And then we have these settings right here that all get sent back to indicate whether or not the message was successful. Again, the first result code, you set it to 0 if it's successful. And then you can send, if you have an error, you send this number to give an error number. If this number is 0, then you send this with the results that you're sending back. It's slightly different, but it's the same in terms of the message that gets sent. If result code is 0, everything's okay. You can send a result string. If you want to send back an error message to the person that sent you the message, you set a higher than 0 number here and you send an error number here. Everybody okay? It works in the source code. I think that helps a little bit there. So essentially, you've got that stuff, and here is a simple little function that was for the send command. So you see here, it got this message, it got this. There's RxM. So it says, it just prints out. The program received a send message, and this is the text that it got right here. And there's one of these functions for every one of those commands up above. This is one of the simpler ones. And this one doesn't send any kind of an error code back because there's really no error to occur. So what we'll do is jump back into a running example. Put this over here, get back to Code Bench. There's our example of this program. There's that same definition of all the commands right there. Come down here and we build it. Everybody have this open? It worked, no problems opening it, I hope? AROS Receiver, yeah. So it built, no errors. Now again, what we'll do is we will use the shell to open the shell in that window right there. So we can run that. There's our AREX receiver. We run it. It says that it opened the library, it opened a port, right? I'm going to open up a second shell window so we have an ability to send a message. So here's our AREX receiver program. It's sitting there now. It just went to sleep. It's waiting for a message. What I'm going to do is go to the parent. And we're going to use the first program we wrote and have there. That's the first program. We're going to use that to send a message to the second program to wake it up. So the name of the message port is AREX Receiver. So it found the port. Actually, I didn't look for the port yet, I don't think. And so what we'll do is we'll send it help. And there's that program right there. That's the receiver that says it got the message. And this is the command that it's sending back to the sender. Here's the sending program. It's saying the hook function ran, there was no error, and there's what it received. Coincidentally, the same thing was sent. So now you have two little chunks of code that just talk to each other. Send a message, and the other one received it and sent back a reply. There's the reply. That message got it. Now, this thing just went back. It's looping. It went back. The message was handled. It's sitting there waiting for another message. So just because we don't want to leave this thing sitting on our machine, we'll run that again. We'll say we're talking to the receiver. This time we're going to tell it to quit. Sent the message up above, it quit. Any questions so far? So, all in all, considering the power of what you've just opened up, you now have a backdoor into your program. You have the ability to make your program communicate with other programs. You have the ability to send messages out, get them, or combine this all together and do it all in one shot. And there are the commands that we get. And obviously you saw how we send it. All good? Now we have one last thing to show you here. Get out of there is one thing here called Arexx macro. So Arexx macro is finally the last little variant on this, where it's kind of like sending a message, except in this case what we're going to do is we're going to call a script and have it run for us. This is just a really simple little script that allows your program to have something the user can use, program, combine, execute, modify, whatever. And your program doesn't have to worry about it, it just gets a little script. So the way this works, like I said, it is the last item in this tutorial here. So what it is our Arexx program, again, has to go through the same steps. It's got to create an Arexx object. In this case, it's going to have a reply hook because we're not receiving commands. We're just going to call a function and wait for something to come back, right? So you go through the same steps like you did in sending a message. You're going to open up the Arexx object. You're going to define a function, a reply hook. Then you're going to define the actual function that gets called when that reply to our macro occurs. Instead of, you go through the same steps like you're going to send a message, except you use the same do method and the am execute. But in the previous example, what we did is here we put a command, like sending help to the workbench. And here we called out a message port, the workbench message port. In this case, it's null, which means the system's going to take it and send it to Arexx itself. And it's going to run a script name here instead of running and sending a message. This is that differentiation between actually just messaging and actually running a little program. So in this case here, this is a simple little command that gets called, and the system's going to look for a function here called Arexx me demo.rex, and this is a script that's in the same directory as your program. It's going to find that and run that script and wait for a response on it. Essentially, it's the same thing as before. You run this, you put your program to sleep with the wait command, and wait for a signal that some Rex event happened. You're going to receive a response, and in this case, again, you have the same thing, result 1 and result 2. Result 1 is, again, 0 is no error. And there are several different levels of warning you can get. 1 is just a warning. Something bad might have happened. 10 is an error. Something really bad, something bad did happen. And obviously, severe error. Run for your life, get as far away as you can. Line up an alibi. It's Steve's computer and I really didn't touch it. So, the format command worked. Oh wait, that'd be 0. So, and if that's 0, then this one here will hold a result. Whatever got sent back by that macro script that we called. These things get set within that macro script. So the Arexx script that gets called can be anything. It can be a whole application, or it could be just a simple thing that allows is something set up by your user that runs your program. Your program could be a paint program, and the script could be something that paints a predefined smiley face somewhere on the raster, right? Now let's go back into CodeBench, and here we have our source code again. As we said, we define a reply hook and all that same stuff. We have a pointer for an Arexx object. We check that the Arexx library was opened. We define all that same Arexx object. In this case, our host name is called Arexx macro. No slot is true again. We don't have any commands because we're null. All we're doing is calling a macro and it's coming back. And we have our reply hook. So we create our object. If that worked, we define our Arexx, our reply hook. There's our function right there that's going to get called when we get a message. Finally, then, we call the do method, and there's our script that we're going to call, and we're going to wait for a reply. Again, as before, we get the mask, and we call the wait function. We wait for our script to run. Again, as before, once our program wakes up, we check to see that we got an Arexx message. And if we did, we handle the event. Same steps like you did in sending a message or receiving a command or anything like that. We handle the event. In this case, if it's a reply, something coming back from our macro, the hook gets called. And then that's it. There's a control C. We dispose of the Arexx object and we're gone. So again, let's get rid of that. Build the project. Project is built. So now what we'll do is we'll open up the shell again here. We're in our Arexx macro. We run the program. Now, you just saw a window pop up. We just went through all the source code. Did you guys see any code in there about opening a window? Well, what's happening is this. This is the Arexx script that we just called. It's a simple little Arexx script. All it does is it changes to send a command to the system. Sends it a DOS command that is a request string right here. It says sample macro script. There's our sample macro script. This is the simple AmigaOS request string. Yes. The Arexx script called the CLI command line program that said, Arexx macro script, this is a macro right there, a macro script running. Please enter a response to be sent back to this is being called by the Arexx script. So now not only do you have a means to create a macro, you have a way to interact with your user even. Well, this being the first macro script, of course, we have to go and, oh, well, here. And we just sent it back. And there's our shell again. So we sent the script, we called the macro. That's the point at which we got our little requester. It sent back its reply. We found out we have an Arexx message. There's the hook. And there's what I typed in to the macro script, and it sent back to our C program. Now that could have been anything. That could have been a whole series of commands that our program knew something to do with. It could have been a message that we sent to AmiRC, and it sent back some string from AmiRC. It could have been calling AmiFTP and logging into a file server and saying, send me a list of files. And it might have sent it all back right there. Yes?
Is there any particular reason that you decided to write the output to a file and then read it?
It just works for me.
You can directly pass calls, can't you?
You can, and you know, I just find that was a simple method that always works for me. There's ways to pipe it and things like that, but there have been times when I had spotty results with that. This works. But there you go. That's the simple little program there. Again, it got the message. That's the hook function. The message was handled. So if we go back to our source code, the message was received. Here's where it got called to the hook function. Afterwards, it says message handled, right there. And then finally, we're done. Oops. We're done. And we have the last thing to do is to get rid of our Arexx object. Just like we did with other things that in Boopsy, or what we do is we simply say dispose of the object. Essentially, you just call dispose object. You have the Arexx object. It's gotten rid of. Now, one of the things about Arexx, you never know when your application is going to get a message. If your application is perceivably going to be getting a ton of messages, who knows? There is a function called AMFlush. So before you call this right here, if you think your program could be getting messages at any time, like you're not in control of the sender and the receiver, then you should call this AMFlush, because that will get rid of any messages that may be pending or falling in line and things like that you might not have dealt with yet. Let's say you have a quit message you got. Call AMFlush to make sure nothing came in after the quit while your program's in the process of quitting. Then you call this and you get rid of your object, quit, your program's done, or goes on to do whatever it wants to. So there you go. You guys have got the 3 examples. Any other questions?
Thank you very much. That's great.
You can add commands, but is there any way to block commands from going through? Like format or delete?
Block commands going where?
Through the ports, so that
if you don't define the command,
you got the right
no. When you go into the oops, going in the wrong direction. What am I doing? When you are defining your commands, right here, if your program gets a command that it doesn't know, if it's not one of these, it's not handled. The Arexx class, it knows which commands your program can handle. Now, like I said, there are ways to make it so it can handle more things than that, but you're getting out of the realm of doing simple Arexx class. You've got to start digging into open up the hood, get into the engine, not just to the spark plugs. So, any other questions? Okay, well then all you guys have to do now is add Arexx ports to all of Lyle's programs. Okay? Thank you, guys.